The plains of South Asia are marked by the vast, sun-baked remains of ancient megacities like Mohenjo-Daro and Dholavira. 4,000 years ago, these were the bustling centers of the Indus Valley civilization until they were abandoned. The precise brickwork found at the Great Bath reflects a master-level understanding of engineering and waterproofing. These urban planners built strictly gridded streets, multi-story homes, and some of the world's first complex urban sanitation systems. This was a society organized around commerce. Intricately carved seals were used to regulate a trade network that spanned thousands of miles, maintaining a standardized administrative system without relying on massive arsenals or monuments to warfare. Despite this prosperity and architectural success, the people eventually left. The once thriving streets and alleyways were left entirely empty. Evidence suggests that no massive invading army arrived to conquer them. Instead, we must look for an invisible force point capable of destabilizing the greatest urban civilization of the ancient world. Early historians often favored a single violent explanation, the Aryan invasion theory. The assumption was that nomadic Indo-European warriors swept into the subcontinent and destroyed the Harappan cities. This conclusion was largely based on the presence of unburied skeletons in the ruins, which were interpreted as victims of a massacre. However, modern archaeology has found no evidence of mass warfare weaponry or widespread destruction levels in the soil. Modern genetic studies have introduced a new layer of evidence. In 2019, researchers successfully extracted DNA from the 4,500-year-old remains of an Indus Valley woman at the Rocky Gari site. The DNA analysis showed no markers of steppe pastoralist ancestry during the period of urban decline. The population remained genetically local, contradicting the theory that they were displaced or slaughtered by invaders. With no proof of human conflict, researchers began investigating environmental data. The evidence points to a threat that emerged from long-term changes in the Earth's climate. Archaeological and scientific data have moved the investigation away from human conflict, focusing instead on a catastrophic shift in the natural world. Approximately 4,200 years ago, the Earth entered a new geological phase known as the Megalayan stage. This era was triggered by a distinct warming of the tropical Pacific Ocean. This distant change in ocean temperature disrupted the Indian monsoon system. The reliability of the seasonal rains began to fail, stripping the region of its primary water source. This chart tracks the declining monsoon intensity. Rainfall dropped by 10 to 20. Looking at the x-axis, it's clear this was a multi-generational drying of the climate, a relentless trend lasting over 600 years. The loss of the summer monsoons undermined the region's agricultural stability. Without predictable water, the surplus needed to sustain large urban populations disappeared. The megacities depended on the region's hydrology, specifically the Ghaggar-Hakra or Saraswati river system. These perennial rivers provided the water security required for massive settlements. As the monsoons weakened, these rivers shrank into seasonal trickles, leaving behind dry lake beds and parched soil. This cut off the cities from their primary lifeblood. This chart tracks the agricultural yield index leading up to 2000 BCE. As the rivers dried, water-intensive crops like wheat plummeted. As yields bottomed out, failed harvests caused widespread malnutrition, and crowding around remaining water sources accelerated disease. This environmental crisis reached a climax around 1733 BCE. The entire region was hit by a devastating peak drought that lasted approximately 164 years. When we compare different environmental stress factors, this data shows that drought and monsoon variability were the dominant causes of settlement abandonment, carrying far more weight than soil degradation or shifting river courses. Without stable water and grain supplies, the infrastructure of the megacities collapsed. The population was forced to choose starvation or leaving their homes behind. The Harappan people did not simply vanish. Instead, they enacted a survival strategy that changed the trajectory of their civilization. Communities migrated away from the dying core region, dispersing eastward toward the Ganges Basin and southward into Gujarat. Here, they adopted a different agricultural model, abandoning water-heavy wheat for drought-resistant millets. This process is known as de-urbanization. It was a pragmatic shift away from megacities in favor of smaller, rural village clusters that the environment could still support. Their former urban centers were left to the desert. Over time, they were buried by sand and earth, becoming unexcavated mounds in a barren landscape. The end of the Harappan urban period was an act of survival. They maintained their population by abandoning their cities and altering their relationship with a changing world. The tragedy of the Indus Valley lies in their level of sophistication. Even with world-class water conservation engineering, they could not prevent the collapse of their urban core. These are the stone-lined reservoirs at Dolavira. They were built to capture every drop of monsoon rain, but they currently sit bone dry. They offer a physical record of how extreme climate shifts overwhelm even the most advanced infrastructure. Long-term weather shifts outlast localized technological defenses. When a rain stopped for 2 centuries, no amount of engineering could sustain the population. Today, we see similar patterns of warming oceans and shifting monsoons. The environmental pressures that destabilized the Indus Valley are resurfacing in the modern world. The ruins of the Indus Valley illustrate a difficult truth. No civilization, regardless of its engineering brilliance or peaceful prosperity, is immune to the overwhelming forces of a changing climate.